This is a review for the vectors chapter that we just worked on. Directions answer each question with the given vectors, and we have 6 vectors across here. Question 1, find 2 times vector v. Well, all we got to do for this is take a 2 and multiply it by the components. So that's -2, -2. This vector, you go left 2, you go down 2. Number 2, find the negative of vector u. That means we just change its direction. So instead of right 3, you go left 3. Instead of up 3, you go down 4. Number 3, add vectors u and v. I have them written here. Add the x components, that's going to be 2. Add the y components, that's going to be 3. Number 4, we're supposed to double the components for v. We're supposed to change the sign of the components in u and multiply it by 3. So I'm going to take 2 times vector v, and I'm going to change this instead of a subtract, I'm going to make it a plus a -3 times vector u. You don't have to change it to a plus and negative. It just makes the most sense for me to do that. I'm going to get -2, -2, plus -9, -12. Add the x components, you get -11. Add the y components, you get -14. So this is a new vector. You go left 11, you go down 14. Convert v to polar coordinates. Well, if you recognize that this is a special right triangle, if we make this vector down 1 and left 1, if we make a reference triangle, so 45, 45, 90, which means the hypotenuse is square root of 2, and it means this angle is 180 plus 45. So that's going to make this vector v, put the radius first, the magnitude, followed by the angle. 180 plus 45 is 225 degrees. You could also do this problem if you don't recognize it's a special right triangle. You could do that the components are, well, no, let me not go that route. I apologize. Number 6, convert this fellow to polar. Well, this is in quadrant 1. We go right 3 and up 4. If we make a reference triangle, it's going to be like this. This is not a special right triangle, but this is a Pythagorean triple. Which makes the hypotenuse here 5, the radius, the magnitude, if you will, all of those things. You can also use the Pythagorean theorem to figure out that this is 5 if you didn't realize it was the Pythagorean triple. You could also use this generic form here, which is magnitude is going to be the square root of the sum of x squared and y squared. And then to figure out what theta is, this angle, I'm going to take tangent of theta is y over x. Therefore, theta is tangent inverse of 4 over 3. Tangent inverse of 4 over 3 is about 53 degrees. So this vector that goes 3 right and 4 up could also be thought of having a magnitude of 5 and a direction of 53 degrees in the counterclockwise direction. Generically, this over here would be tangent inverse of y over x, if you wanted like a generic formula for this. Number 7, convert w to polar coordinates. We're going right square root of 3 and down 1. That's going to be in quadrant 4. So here's our vector. If we make a reference triangle, it's like so. You might recognize this is a special right triangle. It's a 30, 60, 90, which is going to make the hypotenuse here 2. So we could say that vector w, we can say this in lots of ways. We can say the magnitude followed by an angle of negative 30 degrees. It's this way. If the directions say that the angle has to be positive, then we couldn't say that as the answer. We would say that this is magnitude of 2 with an angle of 330 degrees. These are the same answers. Number 8, convert r to component form. So if you want to go full generic formula, component form, it's r times cosine of theta followed by r times sine of theta. If you recognize this is a special right triangle, which it is, you don't have to do any of that garbage. 330 degrees is in quadrant 4. Magnitude is 2. The reference angle is 30. Oh, this is a 30, 60, 90. Opposite 30 is half the hypotenuse. Half of 2 is 1. And then opposite 60 is the short leg times the square root of 3. Make sure that we have the signs correct. We went down for 1, so it's negative. So in component form, this is going to be square root of 3, negative 1. If you would have done this, you would have got the same answers. Although this in your calculator would give you like 1.73 as a rounded number. Convert S to components. This is not S. Let me find S up here. (200 degrees does not give us a special angle. So if we wanted to go, once again, generic, we could say this is going to be 3 times cosine of 200 degrees, followed by 3 times sine of 200 degrees. If you need some help on why that is the case, we can draw this. 200 degrees is going to be in quadrant 3. Magnitude is 3. That makes the reference angle 20. If we wanted to drop this vertical, so we have a reference triangle, we have our y and x value, which we don't know. But then we could say cosine of 200 is x over r. And if you multiply it, and we know the r is 3, if you multiply both sides by 3, you get 3 times cosine of 200 equals x. That's how this comes about. And then similarly, you could say sine of 200 degrees is y over r. That's why this is what it is. Now if we put this stuff into our calculator, we got 3 times cosine of 200. That's negative 2.82. If we do 3 sine of 200, we get negative 1.03. You don't need to do any of this, but if you need to do it to help yourself, you're welcome to. This is the route I would go if you know those formulas. Convert t to component form. Well, this 225 looks like a special angle to me. It's going to be in quadrant 3 with a reference angle of 45, because 225 is 45 more than 180. If the hypotenuse is 1, because that's the magnitude of the vector, then each of the legs are 1 divided by the square root of 2. And if you want to convert that so that you have a rationalized denominator, that would be square root of 2 over 2 for each of those. So vector t has components of negative square root of 2 over 2, because we went left, followed by negative square root of 2 over 2, because we went down. It's important that you get the signs correct. Let me fix that down here. All right, that's a review. If you need more review, go back and look over your notes and homework for this chapter. And any type of question that was asked in the notes and the homework could be on the test.